Bismillah Rahman Rahim. Today we will learn that how neural network update their parameters. So before wasting any time, we will start with a network which have one input layer, one hidden layer, and one is output layer. So initially we are given with weight W1, W2, 3, 4 to W8, and we also have given these values, and our input is 0.05, that is here 0.05. Our input 2 is 0.1, and we also have given the bias 1 or bias 2. So for the sake of simplicity, we can say that every neuron has two things. One is net and one is out. Net mean that every weight which are coming to H1, it will go to net. Okay, and what will be the output of that neuron? It will give us out. So I make it here that let's put it this is H1. Okay, so I told you that every neuron has net H1 and net and out H1. So these are you can say that B1, W1 and W2. So when these W1, W2 and B1 is goes to net H1, and we are using here our activation function, that is sigmoid function. So let's start with the calculation. We can see that net H1 is equal to here we can see that H1, W1 is going to H1, W2 is going to H1, and also I1 and I2. So I1 will multiply with W1 plus I2 will multiply with W2 and plus B1. So here I did same thing here, I1 W1, here I told you I1 W1, I2 W2, I2 W2 plus B1. So we are given with these values. We will calculate the net H1. We will put this net H1 value to our activation function. Every neuron has activated that same activation function, that is we can say that sigmoid function, and it's depend upon you. At output layer you also use software layer or any other activation function, but here we are using in our neural network sigmoid function. So we also know that sigmoid function is equal to 1 over 1 plus e raised to power minus input. You can say that minus theta t, I use here input. So when I put these value into sigmoid function, I have my output H1 is 0.5932. So same like here we will calculate the net H2 and out H2. Here net O1, out O1, net O2, out O2. So we can see that H2 I1 W3 is coming to H2, I2 W4 is coming to H2, and also B1 is coming to H2. So here you can see that I1 W3, here I1, so sorry I1, sorry there is I1 W3, I2 W4, I1 W3, I2 W4, and also B1. So B1 is going to, so we put these values and you will get that answer. And we also did it before that we put our net H1 into sigmoid function. Same here we will do that, and that net H2 we will put our into our activation function, that is sigmoid function. So when you put this value, you will get 0.5968 answers. So now next thing is net O1, and you can see that H1 is coming to O1, H2 is coming to O1, also B2 is coming to O1. So the interesting thing here is you will not know that what every neuron giving you output. I told you that every neuron has net H1 and out H1. So here the output of H1 will be out H1, not net H1, because net H1 is is getting the weights of previous layer, but what it output is, out h1, which is our activation function. So every input, I mean to say, every neuron will get all weights, and then by calculation, either it with multiplying or adding, like here I1 W1 will go to net H1. So every neuron will add to that neuron, and it will output us, out H1, which is our segment function. So here we will note that here out H1 and W5 is going to O1, not net H1, because here is, you can say that here is, there is out H1. So we will what we will write here is the W5 and out H1 plus W6 out H2 and W2. So you can see that W5 out H1 plus W6 out H2 plus P1 into 1. 1 mean here is, we can say that here is 1 present here, so multiply by 1. Matlab, I mean to say here is 1, and you can say that here is B2. So to not confuse yourself, so same like that, W2 O2 will be same thing. Here out H1 W7 out H2 W8 and B2, out H1 W7 out H2 W8 and B1. You will get these answers. Okay, so the next thing we have to know that the error calculation. So error calculation mean if someone gives you initial values. So I told you that so I forgot to write here. Here is our target is 0.01, target value is 0.01, and out2 is our target value will be 0.99. So next thing, after calculating the all output, we will calculate the error function. So error calculation, you can say that EO1 plus EO2, total error will be EO1 and EO2. So and you can use mean square error function. So we also know that target minus out H1, what is our target is 0.01, and what is we are getting here by using these given weights. So 0.01 minus 0.71. 0.7, what is 0.71? We have this value 0.71 our out H1. Here we did it before. 0.71 is our out O1 values, that is here. Okay, so if I put this here, and 0.9 is our target value which are given to us, and what is 0.76, that is our out O2 value, that is here. So when we calculate this error, you will have 0.3005 error. So now we have to update our weights. The next interesting thing here is to update our weights. We start with W5. Okay, and we also know that how we can update the weights. It is equal to W5 will be, it means it's not equal to, here we are updating this W5 minus alpha time derivative of error function. We will take the derivative of error function with respect to weights which we are updating. If we are updating W5, we will take derivative with respect to W5. If we are updating W6, we will take the derivative with respect to W6. So here we can use that. You can see that here I have, when I have calculated the derivative, if I will take those terms which have W5, so I can see that in O2, here is O2, I have not W5. You can see that I have not W5, so I can skip this, because when I take derivative with respect to W5, I will get 0, so I will ignore this. simply. So I take the derivative u1 with respect to w5 target minus O21, which is our error function. So you will come to know this target. What is your target is 0.01 value, it will be 0, and minus out01. What is out01? You will come to know that out01, here is out01, but there is something we have to know. This we will use chain rule here, not we can calculate derivative directly. So here is very important thing, we cannot do this. I do this to understand you that you cannot do this like that. So another thing is you have to know that in back pass or back propagation you have to use chain rule. So I will understand you how we can use chain rule. So you will not do this, I will do this to just understand you. Okay, so here I will told you stepwise how we use the chain rule. So here we can see that we have to calculate the derivative of E01 because E01 have W5. Okay, so E01 with respect to W5, and we know that our E01, here is E01, I mean to say that we take the error function. Our error function depends upon, here is two things, one is out and one is net. So our error function depend upon out01, here is out01, and I write this here, and our out01 is depend upon net 01. Okay, our out01 depend upon net 01, and same thing here, our net 01 depends upon W5. Okay, if you cannot understand, you will revise the video. I repeat again, what is E01? E1 depend upon out01, out01 depend upon net 01, and net 01 depend upon W5. Now next thing, we will take the derivative. So first thing is here, we will take the derivative of this term. Okay, so we know that Et is equal to E01 plus E02. I told you before, I will not use E02 because it does not contain with W5. Okay, so target minus out, so I will get the value what is with respect to out 01. So I will come to know this value, it will maybe out first derivative. So let's start with the second derivative. So here I use some trick. What is the trick here is, I have to calculate the derivative of out 01 with respect to net 01. So here look, I have to calculate the derivative of out 01 with respect to net 01. And what is my out 01? What is my out 01? My out 01 is here. Here out 01 is there. Okay, so there is some trick here that when you calculate the derivative with respect to net 1, here is no net 1 present here. Okay, here is no net 01. I have to calculate the derivative of sigmoid function. So the trick here is, when we basically, you can say that that is the input. Okay, derivative of sigmoid input. So you can see that let's assume this is my sigmoid function, beta is equal to 1 over 1 plus e raised to power minus alpha. When I take derivative of that with respect to my input, okay, so I will come to know that you will do quotient rule here. So you will finally here. Okay, so I can split a square into separate here and I can also add 1 and minus 1 here because it will not affect my original equation. Okay, so by splitting minus 1 here, 1 plus e divided by 1 plus e raised to power minus alpha, and minus here, when you take LCM you will come here. Okay, so when you separate 1 here, so you will come to know here. So, and also this is our initial v where we separate our square. There is same beta. Okay, so I can write here 1 minus beta into beta. That is what is, this is my function. So I use that trick here which I told you before. So I am taking the derivative of out O1. So sigma derivative with respect to input, I told you what will be this 1 minus out O1 into out O1, and I have calculated this value out O1 minus 1 minus out 1.75 is out 1, and I will calculate this. I will come to know this answer. So next our thing is remaining is derivative of net O1 with respect to W5. And what is net O1? I have here what is net O1 is W5 into out H1 plus W6 into, there is something, when I will take derivative with respect to W5, this will be 0, this will be 0, and I will get out H1 just. So I have calculated this, it will be 0, it will be 0, and it will be when you take derivative of this function you will finally find out H1, and we also have the value of out H1. So finally I will take derivative, I will multiply these three derivative which I have calculated. So finally I will get answer 0.081, and I will apply the update rule. What is update rule? W5 will update 0.5. 0.5 is our previous value. What is the previous value? Here we are given with here a W5. Okay, 0.4. So W5 0.4 is our previous value minus, we are assuming our alpha is equal to 0.5. okay, so here is our 0.081 which we will calculate through our derivative function. Okay, when you put this value you will get answer 0.0359. same thing like before, we will update W6. How we will W6? You can see that what will be our, we will take derivative of our error function with respect to W6. So what is W6 depend upon O1, O1 depend upon net O1, and net O1 depend upon, now here is W6. Okay, so we have calculated this value before, and we will use this value, and we will take derivative of net O1 with respect to W6, and you can say that what is net O1. So here the out H1 and W5 and B1 will be 0 because it's act like constant, and you will finally come to know out H2. And what is the value of out H2? It is 0.5968. So we will put here 0.5968, and you will finally come to this answer. So same like that we will update W7, and here W7 depends upon, here is W7. So we will take derivative of EO2. We will take derivative of EO2 with respect to W7. So EO2 depend upon out O2, out O2 depend upon net O2, net O2 depend upon W7. So here ET depend upon out O2, out O2 depend upon net O2, net O2 depend upon out W7. So you will take these derivative with respect to out O2. So I have calculated the value of net O2 depend with respect to out W7. What is net O2? Here net O2 is out H1 dot W7, and this both term will be 0. So I will finally get the out H1. I have, and I also have the value of out H1. So I will take the derivative of this function out O2 depend with respect to net O2. So out O2 is our segment function, so we will use same trick, like 1 minus out O2 into out O2. So we will put the just values and we will find the final answer, and finally we will take the ET with respect to out O2. So in ET, we can say that we have here EO2 target O2 minus out O2. So we have to calculate derivative of ET with respect to out O2. So this both term will be equal to 0, and minus 1 by 2 will multiply to this term. I have calculated this directly, because 1 by 2 here, and when you use power rule, and 2 will be cancelled out. Okay, you will finally get to minus 1 into this answer. We did it before for out O1, so we just put the value and we will finally get the answer. So same thing, before you will multiply these values, okay, and you will finally get the derivative and derivative value, and you will finally update your W7. Same thing for W8. Okay, just get the derivative of net O2 with respect to W8, and what is net O2 we have here, net O2, this term will be 0, you will finally get to out H2. Here we will get to out H2. Okay, so we'll just put the value and we will get the answer. So now you will just update these weights. Now how we update W1? Okay, next thing, we update these 4 value. How we will update W1? So we have to know that we will start from output. Here we will take derivative of ET with respect to W1. So ET depend upon out O1, out O1 depend upon net O1, net O1 depend upon W5, and W5 depend upon net out H1. Out H1 depend upon net H1, and net H1 depend upon W1. But here you can see that I write here ET depend upon out O1, out O1 depend upon net O1, net O1 depend upon, here is net O1 depend upon, not here, it did not depend upon W5, because when you take derivative of net O1 with respect to W5, you will get the answer, but it will not write, because to understand you, here's dt divided by error depend upon out O1, out O1 depend upon net O1, net O1, here is net O1, we did previously net O1 depend upon W5. In that case, when we update W5, so here we are not updating W5, we are updating W1. So what we will do that here net O1 depend upon out H1. Okay, net O1 depend upon out H1, and out H1 will depend upon net H1, net H1 depend upon W1. So here will be these things. So will previous calculation like same will be remain same, like when we take the derivative of net O1, here is with respect to out, because these values we have calculated before. So another value is here net O1 depend upon out H1. So when we do take derivative the net O1, and what is net O1, here is net O1, you will get W5, because this bottom will be 0, so W5. And when you take the derivative of out H1, here is out H1, you will have answer, same answer we did for another segment function. And you can also get the this value, what is net H1. So net H1 here is here, you will get I1, just I1. Okay, and we have the value of I1.05. Finally we will multiply these 5 values and we will get that answer. And same pattern, like this is previous value, this is 0.5 alpha, and this is our derivative function. So when you get the value, we will come to 0.149. Just same thing for w2, w3, w4. Just you will here you will only get here w2 for updating w2, but in the case of w3 and w4, you will have to look these all neurons. If you have any questions, you can comment, and I will solve for the w2, w3, w4. Thank you for watching my video. If you have any question to understand, you can write comment. Thank you.